Brad Williams, Frugal Finance. Let's talk more about volatility. Implied volatility. In an effort to address the challenges associated with relying solely on historical data for calculating standard deviations, some researchers have turned their attention to implied volatility techniques. Throughout this course, we'll guide you through the process of leveraging market data alongside the Black-Scholes model to gauge the stock's volatility. The Black-Scholes model hinges on 5 key inputs, which are then linked to a 6th variable, the call price. With a total of 6 variables in play, any 5 can determine a unique value for the 6th. Implied volatility as a method utilizes the known values of these 5 variables to estimate the standard deviation. This estimated standard deviation is deemed an implied volatility because it's the value inferred by the other 5 variables within the model. Simple algebra, okay? To find the volatilities, we begin with established values for the stock price, the exercise price, the interest rate, the time until expiration, and the call price. We use these to find the implied standard deviation. However, the standard deviation enters the Black-Scholes model through the values for DISA 1 and DISA 2, which are used to determine the values of the cumulative normal distribution. So you can see there could be a circular problem here, and we'll address that here shortly. As a result, we cannot solve for the standard deviation directly. I'll argue otherwise, and I'll show you an example here next. Instead, we must search for the volatility that makes the Black-Scholes equation hold. To do this, we need a computer. Otherwise, we would have to try an estimate of the standard deviation, make all the Black-Scholes computations by hand, and adjust the standard deviation for the next try. This would be cumbersome and time-consuming. Therefore, implied volatilities are almost always found using a computer. For most stocks with options, several options with different expiration trade at once. Some researchers have argued that all of these options should be used to find the volatility implied by each. The resulting estimates are then given weights and averaged to find a single volatility estimate. The one guesstimate is known as a weighted implied standard deviation. In general, this is a good idea because it uses more information. All things being equal, guesstimates based on more information should overshadow estimates based on less information. The law of large numbers. However, some options trade infrequently, which make their prices less reliable for computing implied volatilities. In addition, options way out of the money tend to give the least biased volatility estimates, and many option traders derive implied volatilities by focusing on at-the-money options. So everyone has a different way to compute the implied volatility. One may work better than the others. Consider the following example of an implied standard deviation based on a call option. We assume that X equals 100 and the option is at the money, so that S is equal to 100. We also assume that the option has 90 days remaining until expiration and that the risk-free interest rate is 10%. So we have T minus T equals 90 days and R is equal 0.10. The call price, $5. The stock price, 100. To find the implied standard deviation, we need to find the standard deviation that is consistent with these other values. To do this, we can compute the Black-Scholes model price for alternative standard deviations. We adjust the standard deviation to make the option price coverage to its actual price of $5. The sequence of standard deviations and corresponding call prices below show this, well, the corresponding example I'll show you next. In our example, we first try 0.10, which gives us a call price of $3.41. The price is too low. Thus, we know the correct standard deviation must be higher because the call price varies directly with the standard deviation. Next, 0.5 results in a call price of $11.03, which is too low. So this is a trial and error approach, and what I'm going to show you next can be done with Excel and Solver. The standard deviation is 0.185 through trial and error. It equates to $5, where the standard deviation is 0.185. That's a general way of doing it. I'll leave it at that. And next, I'll show you an example. You can either use it or not. Brad Williams, Frugal Finance. Thanks for watching.